Good afternoon. It's good to see everybody here. My name is Ed Schaller, and I'm here to talk about WebSphere application servers, JSP engine. Good, and some work I did with that, and what turned out to be a very interesting exploit. Out of curiosity, how many people here actually run or are familiar with WebSphere application server? So a fair number. Okay, so maybe I can move forward through some of this fairly quickly. This is a rather complex exploit, but it's pretty simple when it comes down to it. And it's a little unfortunate when your screensaver comes on. If I trip, first of all, this is our outline. The slides are going to be on the website as soon as I put them up there with the exploit and such. So we're going to talk about what WebSphere application server is, talk about JSPs and nulls, the WebSphere plugin and nulls, webinf, you see it there, and we're going to have a demo and talk about the fixes and extras, and should be good. So, first of all, WebSphere application server's architecture. WebSphere application server is IBM's JEE application server. It's one of the more popular JEE application servers, at least according to Gartner. It's up there with Oracle and Microsoft as the top three. It's heavily used in the financial services industry and in the insurance sectors. And it's not very cheap, so I'm probably not going to go buy it for your own website. But there is a time bomb free version online, a trial you can go and you can download. So I have to warn you that I have on the best authority that the initials WAS are pronounced WAS, but I always get it wrong and say WAS, so you can laugh at me every time I do that, whatever. So anyway, here we have the common network architecture that you usually see in a WAS deployment. You have the client browsers obviously on the internet that then connect through a firewall to your web servers, and those web servers then redirect through the HTTP the WAS web server plugin into the actual web servers. This is done with a HTTP connection that is handled by the web server plugin. The web server plug, first of all, this is the common architecture as IBM shows it. If you look at this, it's hard to see, I realize, but the main features here is that the big gray box is WAS itself, and you have the web server plugin in between it and the internet. So realistically, being that the web server plugin forwards everything into WAS, if you compromise a web app on WAS or WAS itself through the web container, basically whatever you compromise has full access to most of the internal resources that WAS does, with some exceptions depending on the network deployment that's done. So plugin is what's in between it and the internet. I'm getting ahead of myself. And more application can do all that. So the web server plugin is what we need to describe a little bit first to understand. I'm going to refer back to this architecture because we're going to jump around between the different areas to understand it. This is basically an extension module that sits inside the web server, whether that be for Apache, IBM's Apache, which is the IBM HTTP server, IHS, IIS, several other ones including Lotus Domino and things like that. So basically it just connects straight via HTTP to the actual WAS instance's web container. It adds special headers to keep track of where the client came from and such. So it's mostly used for load balancing and failover, so that if one application server goes down, it detects that, and then it forwards to a different application server in turn. One thing that is important to realize about the plugin if you're dealing with a WAS installation is that its primary purpose is not for security. In fact, it's really not to do anything with security. In some cases, I see people actually trying to do blocking rules on IHS and such to try to protect things on WAS, and this can cause issues as we'll talk about a little more later here. So, let's talk about the URL handling and the plugin itself. Not all of the requests that go into the URL plugin on the web server actually get forwarded back to WAS. What it does is it bases the URL configuration, it bases on effectively the same sort of things that are done for the web container itself, from the web.xml and from IBM's extensions configurations inside the WAR file that you're running on. So, as we know, these are simple file globs that get pushed in. They are matched in sequence. The web server plugin is actually very simple, although it's frequently misunderstood. So if you're asking for a servlet, it forwards it in. If you're asking, if you have a simple glob, it forwards in. And what we're going to be talking about is start of JSP. Anything that is JSP, it forwards in. If you have the web server, the WAS feature of file serving enabled, this is a kind of an IBM specific function that if you don't have it enabled, static content inside your WAR does not get served. If you do have it enabled, it does get served. So if you have it enabled, all the connections get passed from the web server into WAS. This is one I see misunderstood a lot of times. If a match occurs, the connection is forwarded in, much like a reverse proxy. Otherwise, the request is handled for the web server. The reason for this is it's usually used to handle static content from the web server as a speed optimization, so that the static content gets served by IHS or Apache instead of going all the way to WAS and served from Java. So this is just frequently misunderstood. It's amazing how much I see it. If you're interested more, there's actually a paper about it that IBM has that's referenced in the slides I recommend looking at. And it's actually for an older version of WAS, but the plugin actually hasn't changed much in quite a while, actually. So now let's talk about JSPs and how they handle null. Now we're going to toggle remove from the plugin here onto the WAS instance, the WebSphere application server. And let's talk about strings. I assume that most people know about strings. Strings under Java, the operating system sitting underneath Java is written in C, which of course has null terminating strings, and which means that you cannot put null characters into a string and have them used later on because it terminates a string that's being used. Whereas Java is a counted string that can have nulls in it. So the big question is, of course, that we're going to start with here is what happens if you try to open a file in Java like test.txt/0, so with a null character in Java? Well, actually you get test.txt. This has been known about for a very long time. Formally, just the specific instance has been talked about some people on the web, but it's been known and used in Tomcat exploits for quite a while. So what about the JSP engine inside of WAS? How does it deal with a null character coming in to WAS? JSP handling is very simple. It locates the file, it translates the .jsp into Java, and then it compiles it into a servlet and runs it. So what happens with WAS, or at least WAS before it was patched, if we request %00.jsp for a arbitrary file inside the WAR? Well, the answer is it actually compiled it as test.txt as a servlet and runs it as a JSP. This is similar to what I'm not even trying to pronounce it. Those are the characters in the web. I didn't make a mistake. It's found in Tomcat. If you're here, I really apologize. So this allows us to read files through the JSP engine. This may seem not too useful, but we'll see how this can be added to in a series to actually make something useful happen. So basically, if we have our context root for a web application, we just append %00.jsp to the end of it, and we'll get the file. Obviously, we have some restrictions on what files we can get. We can't just get any file from the web server we want. It must be in the WAR file, which is usually expanded. And we can't read files in metainf or webinf. And it must compile and run as a JSP, which actually isn't too useful unless file serving is turned off and you're trying to get files that aren't put on the IHS instance that's serving static contents. So the question then comes, as you're looking at these files, is what's a valid JSP? Turns out that basically anything that doesn't include a less than % is a valid JSP as far as the WAS JSP engine is concerned. HTML usually qualifies under this, XML. Most text files, then you get some really weird ones, like you can download zip files and jar files. I didn't know these compiled as JSPs, but they do. Most class files also do. So you can get a lot of interesting things through the JSP engine in this manner. Still not doing anything too interesting, but what about directories? For some reason, and I really don't know why, if you open up a directory in the same manner in WAS's JSP engine, it gives you a list of all the contents of that directory. And I'm really not sure why, because if you open up a normal file in Java from like, you just do a file, new file object and open file input stream, it doesn't happen. So they must be doing something special here, and I haven't been able to track that down in the time I've had. So basically, you can request your context root with a null character after it, .jsp, and you can suddenly get a directory listing, which is obviously a lot more interesting than just getting the static files, because they have to have directory listing enabled, and most sites aren't going to be doing that, we hope. There are times when you actually have to use a period in front of the directory. This is usually the case with the context root, where you have to do %00. Interesting enough, in some cases you can actually do ..., but it has the way that WAS handles the ..., normalization and checks to make sure you're not getting outside of the WAR is pretty specific, except it only checks for ///. So you can actually use this to read the contents of the exploded exploded ear. It's kind of one of these things where you see it and you're like, oh, I can almost get those files, but I can't. So it's rather frustrating, honestly. But you can do it. So this is a lot better than just serving up static files to the JSP, because suddenly we can list and enumerate the internals of your WAR and what files that you may have accidentally left in there in terms of JSPs or other files that are being added to the WAR in the process of this application running, which sometimes in and of itself can be a really lot of interesting information. I dealt with one application that put all its logs inside the exploded WAR. So once you found out the directories, you could get them all. So we have to circle back here and go talk about the WebSphere plugin. In most instances of WAS, you're not going to see direct connections to WAS that aren't going through the plugin or some sort of proxy in front of it. And there are good reasons for this, primarily dealing with speed and static content especially. So the plugin wasn't really designed for security, but in some cases it gets in the way of insecurity too. So I don't know if that really means it's a security device or not. But the problem is that going for a null byte in WAS is easy. But the plugin is written in C, and so it really doesn't like the null character. It terminates your string, and instead of getting your test.txt, you get test.txt, which WAS then just tries to serve out as a normal static file, and if you're not serving static files, then you can't get it, or if you're trying to do a directory. So the next challenge in this puzzle in terms of how to actually do something useful with this vulnerability is to figure out how to get nulls past the plugin. So character encodings. This also qualifies as one of those things that if you think something is generally known by the industry, check. Most of the character codings we deal with are either ASCII, ISO, Latin in the United States. Internal to Java, you have UTF-16, UCF-16, UTF-16. And, but what may not be known is that UTF-8 is actually how Java reads strings natively. So even though it keeps it in memory in UTF-16, it actually reads them as UTF-8. And so UTF-8 is a multi-byte character encoding. It's actually a rather elegant character encoding. If you follow the character encoding improperly, okay, if you just do it a default implementation and don't really think about it, single byte characters, and actually any smaller than the full maximum bytes characters, can be actually encoded as multiple bytes. This is explicitly forbidden by the spec. But who follows specs? I mean, come on. Actually, there's a lot that don't. You may remember there have been a lot of Microsoft IIS exploits that have utilized this. And it turns out that Java also used to do this as well. It decodes the really long ones. This was made known as part of another Tomcat vulnerability by Simon and William, and I'm not going to try to pronounce that sentence, I'm sorry. It was fixed by Sun in their JVM quite some time ago. And it was also fixed by IBM. They share a lot of common code, and so they share a lot of security fixes. The problem is that for some reason IBM's fix didn't work. It actually has to deal with the fact that Sun's JVM now by default uses NIO. And so when IBM took that patch and applied it to their JVM, they didn't think about the fact that their JVM doesn't use NIO by default to read strings, and apparently they never tested this. So one of the morals of the story is test your security patches. This has really been fixed in these new releases of the JVM, very thankfully. Unfortunately, this is not any WAS fix packs yet, so you're still looking at having this particular encoding issues in WAS unless you actually install JVM by hand. I don't know if they're going to do an iFix of this. The IBM folks have been very nice about all this, actually. So, so let's talk about UTF-8 then and what we can do with that with the WebSphere plugin. Well, the plugin is in C, and it handles single byte characters, so ASCII and ISO Latin, and it doesn't know anything about UTF-8, and especially not overly long UTF-8 characters. So, if WAS is in Java using a JVM that accepts overly long UTF-8 characters, then we can just, instead of doing a %00, we can do a C080.jsp, and suddenly we bypass the plugin's problem with the null, and we get our nulls to the backend Java in WAS, and we can actually get these files. So, plugin is no longer an obstacle to doing anything fun with this. This gets a little bit better. So, we mentioned that webinf and metainf, again back here on WAS, are not accessible. If you look at the spec, the service specification explicitly says that you're supposed to return a 404 for anything inside metainf or webinf. This has actually been a source of major problems for a long time. If you actually go and grep all the class files in WAS, you'll find that it's checked a ridiculous number of times, and they still missed one. There may be other ones, unfortunately. It turns out that their file serving servlet that handles when file serving is enabled actually allows a /webinf.web.xml, so you can actually grab files outside of the webinf directory. If you're not familiar with Java web applications, this is where all your configuration is. This is where a lot of your code actually is too, that you can then download and decompile. So this was fixed in PK 64302. A potential security exposure with the file serving feature enabled. There was no details released about this, so there may be other things that were fixed in that same fix pack. I'm not sure. I never really analyzed it, but I know it didn't work afterwards. So surely they didn't just check this in the file serving servlet. Well, yeah. So if you do a / in webinf, you can actually get it through the JSP engine as well, which is obviously a problem. The plugin also, however, normalizes paths, so we have to play our encoding games again to get around that. But in which case, we can still go in and get the webinf.xml, the main configuration for your web application, by using %0, %AE, which is an overly long period, in our path, which the plugin does not recognize, and then our %0, %80, which is overly long null byte, and suddenly we actually get the web.xml. This was fixed along with the %00.jsp issue in PK 81387, which I was surprised. I was talking to one of the IBM security architects, and he said this was the only number he can remember for fixpacks, so they worked really hard on it. Possible application source file exposure, which hopefully everybody has applied at this point. This also works for metainf in case you want to go look at things that are left in there. So the big question is this the whole truth and nothing but the truth? You can actually make possible application source file actually be remote code execution in many instances. So again, back here in WAS, instead of the plugin, we look at JSP striking back. If you remember, we locate a file, translate the JSP to Java, we compile it, and then we run it as a servlet. So if we can get a file into the WAR, we can get remote code execution through this method. So I was looking at a web application, and I had an interesting discovery playing this game with webinf. Here's a listing of the directory of webinf, and there's this attachments directory. Does anybody know what that attachments directory is? I'm just curious. So what it turns out to be is that Apache Access 1 implements SOAP with attachments. This is not Access 2. We're talking about Access 1, which is a little older. Okay. For those of you not familiar with SOAP with attachments, it is implemented very similar to how email is. It uses MIME headers and actually goes through and attaches things as MIME entries, MIME bodies to the main request, so that you have a SOAP, your SOAP envelope with all of its goodies, and then you have your attachments that are referenced from your SOAP service. Okay. When large files actually go through Access, it caches them to disk so that you're not, running your application server out of memory in the process of handling a SOAP attachment, anything over 32 kilobytes, and by default, these get put into the webinf attachments directory. So this directory is created if not present at startup, and guess what WAS as JAX RPC implementation is based on? But not their JAX WS implementation, which is of course based on Access 2 instead. So Apache Access actually has some interesting bugs that make this less true than you would think. It's very good at optimizing how it reads in attachments from the network. So if your service actually doesn't handle attachments, it doesn't even bother reading them. So it doesn't get to the point where it actually caches on the disk. It's just rather frustrating because we'd have to find a SOAP service that handles attachments. And at least in where I work, we don't have very many of those, if any. So it's a lot rarer to have this, which makes our attack a little harder. So it occurred to me, well, what happens if we just, you have a series of MIME attachments, instead of putting the SOAP body first, like everybody does, what if we put our attachment before the SOAP body, and, so that our attachment has to be read before it reads the actual SOAP message? Well, it turns out that actually works, but there's this other little bug in Access, the way it handles thread local variables. that if you do that, it actually saves it to another file system directory, specifically where your temp directory is for Java IO, which is usually /temp on Unix machines. So great, we can DOS 2 file systems instead of 1 with Access, but that doesn't really help us very much. So let's talk about SOAP encoding. SOAP encoding actually allows you to reference attachments. We just need to reference that attachment and it'll read them in. It allows this href attribute to be applied to parameters and such inside our SOAP message. So when used with Apache Access 1, it'll actually parse the attachments and cache the large ones to our disk where we want them inside our webinf directory. So this, of course, requires that we have a web service that's actually using SOAP encoding. So we're talking here about RPC encoded messages as opposed to document literal or RPC literal, which are different methods of using SOAP. I swear this is not my fault. Access 1 provides an interesting feature, which unfortunately is not present in the WAS implementation, the WAS extension of Apache Access 1. So we can't use it directly with WAS. And what happens is that the client, for whatever strange reason, can actually send a fault to the server as its initial request. Usually this isn't something that should be happening, so not surprisingly the server says, what? Send me faults. I'm supposed to send you faults, not vice versa. So, but the nice thing is that it parses it anyway first. And just for fun, SOAP faults use encoding, SOAP encoding. So we can send attachments with them too. So not only are we sending a fault, we're sending a fault with an attachment. And it also doesn't require any web services to be actually configured in Access 1. It just requires the exposure to the Access 1 servlet itself, which is plenty enough to actually get this to work. So let's talk about actually how to use this. We have to put together a lot of things here to make this actually work. First, the attachment file names are fairly random. And the first thing we have to do to actually exploit this is we have to connect to WAS, use the JSP bug to figure out what's currently in the attachments directory. Baseline that, then we send up our attachment as a SOAP fault. Then we get a directory listing after that, and we go through and find the JSP that we put in there, the file we put in there, and we request it as a JSP, at which point the file is transferred to Java, filed, and run, which means we've achieved remote co-execution on WAS with all of it. So to demonstrate this, we have a little cute SOAP shell over JSP, which baselines the attachment directly, uploads the JSP with the SOAP fault, finds new attachments, and then checks that it actually has this attachment in case the service is already handling attachments, in which case you have to find your own. There is a race condition here on some servers, depending on how they're configured and how the timeout is, especially in WAS instances deployed for development instead of production. So in our case, we need to copy our JSP quickly out of that directory so it doesn't get removed while we're using it, which is kind of frustrating. And then it processes standard input and standard output from command line to over HTTP to the server. So if you're going to use this, and finally when it's done, it removes itself. This is exceptionally noisy in the logs, so it's not exactly very useful for anything but a demo, but it's great for demos. So let's do this. Here I have a WAS 7.0 instance, 7.0 fixpack 1, which is the last fixpack that was vulnerable. Inside of this, I have the demo application, which is going to be on the website this afternoon, that is running. And it actually is being accessed through the plugin, which gives us our plugin page. And the access servlet is actually mapped to just /access1. At this point, we have a shell script that is running our Java exploit that takes the context root directory and then the relative path to the Access 1 servlet and gives the command name that we want to execute. And with this case, we want to execute the shell. So in his case, we see it updating and baselining it, and then we're hitting it very quickly in this case because this instance is running in development mode, and therefore it removes our attachment very quickly. It then finds it, baselines it, and it gives the shell of the server on the server. So, and we have full access to the server that's running WAS. This tends to make WAS admins really unhappy incidentally when they start executing commands. It's actually much more efficient if you actually want to exploit WAS to actually, run stuff in your JSP and have stuff natively stored inside of WAS instead of creating a shell, because most admins get a little fishy when they see a PS list that includes a shell being launched from WAS, because it really shouldn't happen. So afterwards, we just remove the JSP and we're done. So we clean up after ourselves, and hopefully nobody noticed. But with that exploit, it's very noisy, so people will notice, hopefully. Not that you couldn't do it a different way. So let's talk about fixes. This has been fixed. First, we have affected platforms. WAS runs on an unbelievable number of platforms. I counted 15, and I'm pretty sure I'm wrong. I'm pretty sure it's more than that when you consider everything. AX and Linux were the ones I dealt with explicitly, because that's what we run. Case-insensitive file systems actually are interesting because they're not vulnerable to the %00.jsp bug. And this actually, I believe, has to do with an earlier fix for security problems with case-insensitive file systems. The only one I know of is, of course, Windows that WAS runs on. So if you're running Windows, you don't have to worry about this one. Well, you still have to worry about the encoding issue, but not. The overly long UTF-8 encoding obviously depends on the JVM that's in use on the application server. In non-IBM JVMs, hopefully this will be fixed before the IBM one at this point. Those two that I know of are going to be HPUX, which runs an HP VM, a JVM, and Solaris, which runs the Sun one, obviously. In terms of versions, 6.0 was fixed in 6.035, which is the same as 6.023, which is fixed-spec 35. 6.1 was in fixed-spec 23. 7.0 fixed-spec 3, and other versions you can apply the iFix. There was also fixed specs for 5.1 and 5.2, but I don't have access to those to try them. So hopefully you have this done. Let's talk about IBM for a second. 15 platform variants that I count. I'm on the low side, I'm pretty sure, because I didn't count things like IA64 for Windows and such. 4 maintained versions, about 60 different variants. Can you guess how long it took them to fix this? Ballpark? 8 months? It's pretty. How about 2 weeks? I'm impressed. How do you do 60 different variants in 2 weeks and have a public fix them from the time I tell them? I was very, very surprised. If you are dealing with IBM for security vulnerabilities, I would recommend that when possible, that you always submit them as a PMR, that is a service request, because that is how they handle everything related to their software. And if you don't do it that way, you're kind of in the la-la land where they're not sure what they're doing, and you may get forgotten about. But if you do as a PMR, they will get it done, and sometimes they can do absolutely amazing things, like 2 weeks to fix this sort of thing. They also ticked off a lot of people, too, as we'll talk about in a second. Their fix is actually very elegant. This is, my pseudocode for it. Basically, they look at the file they're trying to open, and they ask the operating system to canonicalize it, and they compare the two, and they say, is this really the file I'm opening? And if they don't match it, well, throws a 404, which is nice. This actually has problems with it. It caused a lot of problems with people who are running on Unix systems that, for whatever reason, were putting symbolic links in their exploded wires, because that will fail. That test right there, because the canonicalization of a file path in Unix will actually return the absolute path, not the symbolic link. So that was a problem. There's some fixes for that. I haven't looked at it specifically. The WebInf fix is not quite as elegant. They just check to make sure you don't have WebInf anywhere in the URL path, which solves this problem. It does work very well. My guess is, though I haven't tried it, if you try to have a subdirectory that's called WebInf, it won't work, but hopefully that shouldn't happen too frequently. So before we talk about workarounds, we're going to talk about some workarounds that you can do. But first, you're more than a year behind on patches at this point if you're working workarounds. It's a really good thing you're not running other servers. So the best workaround that I like the best is actually to disable the runtime compilation and reloading of JSPs. This is a little frustrating. The Information Center will actually tell you can disable it at the application level. This is done with putting some specific features into the IBM web etc.xmi. There used to be a way to do this at the container level. It's still in the Information Center, and I can't get it to work. So I don't believe that it's supported anymore. This makes the fix a little harder because you're dealing with it at an application by application level instead of actually doing it on your entire server or your cell. Of course, once you disable runtime compilation JSPs, you're going to want to make sure that you pre-compile your JSPs, either deployment time or batch compile them before you go in there. Doing that works great. The other way to do this is to block JSPs. which we have to talk about a little bit. Of course, if you actually need direct access to JSPs, this is not going to work. It's going to break your application. But for a lot of people these days using Model View Controller, whether that's Struts or Spring MVC or some other web framework, usually your JSPs are only in views and only forwarded to internally, so you actually can do this without breaking stuff. There's a lot more issues here that we can talk about before blocking JSPs. So, I got a question. What do the following byte sequences have in common if the title doesn't give away? So, 80 through C1BF. I'm not going to read these. They're all invalid byte sequences for UTF-8. Any guesses what the IBM JVM does with them? This is the fixed JVM. Do you think this is a problem? It's an empty string. This actually, in the unfixed JVM, it only does it for 80 through FF because they didn't consider overlong invalid anymore. This is obviously very useful for IDS evasion because you can throw as many invalid UTF-8 characters into your URL as you want, and the IBM JVM will ignore them when it parses them. So suddenly, you can be, requesting a whole path and, replace every other, add a new character, new invalid, %80 or something invalid UTF-8 code anywhere you want and get around it. Of course, this also makes it very difficult to write JSP blocking rules. So if you're going to write a JSP blocking rule, you have to worry about this. And there's lots of fun games you can play with encoding, these encoding issues, honestly. The other thing you need to remember if you're going to try to block JSPs is that there's more than .JSP that by default with WAS. Start.JSP, Start.JSW are also handled as JSPs, and in some cases also Start.JSPX, of course, if you're using newer versions. So if you're actually going to go and try to do blocking JSP rules, you need to actually use the UTF-8 all day long decoding. Got to keep that in mind. Got to keep the decoding of invalid ones, the replacement string, and of course multiple JSP connections, extensions. At which point I would really recommend applying patch because this is not trivial to do. One of my friends tried. He did a good job on it actually, but it was not very pretty. So a note in browsers, if everybody goes home and starts playing with this, don't forget that your browser will normalize this, your dots and such. It also does the same thing with URL encoding in some cases. Firefox and Windows actually, for some reason, will translate a %2e into a slash, which it won't do in Linux, interestingly enough. If you're dealing with the plugin and load balancing, you need to hit the same server every time, obviously. Otherwise, you're going to be bouncing between servers, and the JSP that you uploaded may not be on the server you're hitting. So server affinity with the servlet plugin, the web server plugin, is handled by the JSession cookie. So JSPs by default, when they're first run, actually give you a cookie. So as soon as you baseline the attachments directory, you just need to make sure that you keep your cookie, and you should be hitting the same server unless that server goes down. They never go down, right? So on the Defcon CD, there's one text file with a URL to a website because I missed the CD deadline. Sorry. But on the website, and I'll be uploading this, there are slides. There's a tool to do the mapping of your JVM, which actually will list out all of the different byte combinations for UTF-8, go through them, and then show you what they're being converted to, and also what they do with the file system. Actually reveals some other issues with IBM JVM if you're interested. There's also a sample application that has nice URLs to try this on your own. Obviously, you'll need to download the trial if you don't have WAS yourself. There's also an exploit for the access1 faults that I showed you, the same one, with the source code for all of the above. So there's a lot in there, and you're more than welcome to send me an email on this and tell me that my code sucks. I would appreciate that, actually. So in conclusion, anytime you're dealing with a barrier between one implementation of a specification and another implementation of a special specification, whether it's UTF-8, whether it's HTTP, whatever it is, this is usually a really great place to look for bugs. In this case, of course, we did between the plugin and Java, and then between Java and the OS. Now, sometimes we have to deal with multiple cases. Some people, I talked to people about Java, and I had to do Java for my job for the last several years. And not a lot of interest in Java, but these same sort of things actually happen in managed environments like Java and .NET, and Java, of course, not immune to that. And what I really like about this is that you have a small series of these little vulnerabilities that you write down your reports as low or medium and never get fixed. But sometimes when you can weave these all together, you can actually make something that really makes a big problem. So, with that, are there anybody who has questions about this?